Before jumping into composition of functions, there's a couple of skills that we need to review, including how to evaluate function notation when there's a number and evaluating function notation when there's an expression. Now, function notation is just a letter that we've called the function to be able to differentiate it. And then what's inside the parentheses is what our variable is going to be. So this is the function called w, and x is the variable used in it. So when we say w of 5, what we're going to be doing is replacing that x with 5 throughout the rest of the problem. So w of 5 would equal -2 times 5 squared plus 3 times 5 minus 12. Now I am going to work this one out by hand just to remind us of our order of operations. So we have to square the 5 first. We cannot multiply the 5 by the number in front until we have done the square or the exponent first. So -2 times 5 squared, which is 25, plus, now 3 can be multiplied by 5 in this step because there's no exponent. So 15 plus 12, actually it's minus 12. Then we can do -2 times 25, which gives us -50. And then -50 plus 15 gives me -35. Minus 12 gives me -47. Now, typically what we'd like to see is for you to type that all into one step in your calculator. So you would type -2 parentheses 5 squared, and we always put whatever we have raised or whatever we have inserted or substituted into the problem in parentheses. So -2 times 5 squared plus 3 times 5 minus 12, and we did get -47. It also asked me to be able to find w of -4. So we are going to take and replace -4, or replace x with -4. So w of -4 means that I'm going to do -2 times parentheses -4 squared plus 3 times our -4 minus 12. Now this time I am going to go ahead and use the calculator because we've already reviewed our order of operations. So -2 times parentheses -4 squared plus 3 times -4 minus 12, and we get -56. Now, one question that I usually get from students is, what do I do with this? Well, this is just telling us what we're finding or what the question is. It's like repeating the question. So we don't then divide by -4 or anything. We're not trying to get W alone. Our answer is -56, and we don't have to write anything in front of it. For this one, our answer is -47, and nothing needs to be written in front of it. Let's take a look at what happens when we have expressions to be able to plug in. Our first one tells us that we're looking at function d, so this function, and we're replacing the x that was in d with 3y. So we have d of 3y equals, we have 3 times, parentheses, because I'm substituting in, 3y squared plus 6 times, there's that 3y again, minus 10. Now this is not something that we could just type into our calculator, so we do actually need to know how to simplify with our order of operations. Now, one of the common mistakes that I see from students is that they try to multiply these two together to get 9, and then they square it. But you can't do that because the order of operations says that we have to square first. So we'll bring this 3 down, and we'll have to do 3y squared, which is 9y, 9y squared, and I should have that parenthesis around the outside of my square. Then 6 times 3y gives me 18y. Now we can do our multiplication. So 3 times 9y squared gives me 27y squared plus 18y minus 10. And that's as far as I can simplify, so that is my answer. Now in number 3, we are plugging y cubed into the c equation for x. So we have c of y cubed, and we'll start with 4 times, and instead of x, we'll put y cubed in parentheses. And that x was cubed, so another cube goes on the outside of the parentheses. Minus 5 times y cubed squared plus 2. Now, exponent rules, which you've learned in a previous course, say that we have to multiply exponents when we have an exponent that's being raised to another exponent. So we'll have 4 and y to the 9th minus 5, and this will be y to the 6th plus 2. And there's no simplifying that can happen. So that will be my answer. Now, number 4, we've graduated a little bit further into having 2 terms. So we are going to be putting 2 terms in for x. Up until now, we've only done numbers and then other monomials that have variables with them. But now we'll have 2 terms. So we need to pay special attention to what happens when we raise those 2 exponents. So we'll use the d equation like it asks us to, and we want to find d of x plus 3. That means that we're going to plug in x plus 3 into each of these x's. So 3 times x plus 3 in parentheses squared plus 6 times, there's another x, so x plus 3 minus 10. Now, listen very carefully. X plus 3 squared is not x squared plus 9. You cannot distribute a square across 2 different terms. Instead, you need to remind yourself that what it means to be squared is that it's something times itself. So we will need to multiply x plus 3 times x plus 3. So we'll have x squared, 3x, 3x, and 9. So this 3 will come down, and x plus 3 squared is x squared plus these 2 will become 6x plus 9. If we would have just squared each term, we would have been completely missing a term. So please make sure that you are remembering that something squared means something times itself. Now this 6 can be distributed inside to become 6x plus 18 minus 10. The 3 needs to be distributed to give us 3x squared plus 18x plus 27 plus 6x, and we can do 18 minus 10 to give us 8. Combine like terms, and we have 3x squared, 18x, and 6x will give us 24x, and then 27 and 8 will give us 35. And that's as far as we can go. So each of these have been just baby steps to build us up to performing compositions of functions. So there are 2 ways that you can show that two functions are being composed or functions are being composed. The first is with an open circle that's a little higher and a little smaller than a normal size O, and it goes in between the two names of the functions. And then the X would go outside, and oftentimes you'll see brackets around the two names. The other way is with parentheses, and this is often the way that most students are more comfortable. And so we can use these interchangeably just to make it look a little bit better in our minds. Now, how would I read this? You would read this as f of g of x. And of course, f and g can be interchangeable with any other letter, just whatever it's called. Now, what does it actually mean when we say that we have composed two functions? It means that we have substituted one equation or one function into another function. Now, there are two ways of thought here, and they both come off of our different notations. For this notation, you will always start with the innermost parentheses and work your way outwards. And again, that's when it's written with the parentheses. Now, if it was written like this with the little bitty O, the open circle O, you would start on the farthest right and you would work your way left. And that would be when it's written like this. Now, there is a little danger in falling into a trap and thinking that you can change the order around, and you can't. F of g of x is not always the same as g of f of x. Now, there will be some times that they are the same, but that really has kind of more of a special case scenario. Generally speaking, they are not guaranteed to be the same. Let's take a look at some examples. So for example 1, we have been asked to find not only g of h of x, but the reverse as well, h of g of x. Now remember I told you that this notation, it's interchangeable. So if this makes you a little more uncomfortable or is more confusing to you, you can change it over to be the parentheses. And we would just look like this, g of h of x. Now if rewriting that sounds like a whole lot of work that you're not willing to do, it's okay. I feel you. We can just put our parentheses like that. Either way will still get us to the same point. Now, what is g of h of s asking us to do? It is asking us to take the innermost parenthesis, so in this case, x, and make sure that it is put into h. Well, that's already done. X is my variable. But we are going to take h and now put it in to g. So we are going to take this h equation, 4x minus 1, and we're going to replace x with it. So we'll have negative 3 times our 4x minus 1. Then we can reduce. Negative 3 times 4 gives me negative 12x, and negative 3 times negative 1 gives me positive 3. That's all there is to that. To go in reverse, So x is already my variable for g. So we're going to take the g of x equation, which is negative 3x, and we're going to replace x in the h equation. So that means that we will have 4 times, in parentheses, negative 3x, and then there's a minus 1. So 4 times negative 3x gives me negative 12x, and I still have minus 1. So notice when I did the reverse, it was not the same. Let's take a look at the next one. So again, we can change this notation if you'd like. I'll keep the bottom one the same so you can get some practice using both. But we are taking, since x is already the variable that's been used, we're taking h and putting it into g. So we are taking x squared plus x minus 1, and we're replacing x. So we have 5 times, and instead of x, here comes the h equation, x squared plus x minus 1. So we can simplify that and distribute that 5. So 5x squared plus 5x minus 5. And then we can go the other way around as well, which means since x is already being used in the g equation, we're going to take that g equation and plug it in to h. So we are putting 5x into each of these x's. So we have 5x in parentheses squared plus 5x again minus 1. So 5x squared is 25x plus 5x minus 1. Let's do one more. So since we did 3 with the notation of parentheses, I'll leave these last 2 notations alone as well. So we have 3 of each. So right side to left side. H is already, or x is already the variable in h. So we're going to plug h into g. So that means 2x squared minus 3 is going in for x. So 2x squared minus 3, and then the rest of the equation plus 2. Well, there's nothing that needs to be distributed. We don't need to raise it to an exponent, so I can go ahead and combine negative 3 and 2 to be negative 1. Let's go the other way around. So x is already in for g, so we're going to plug the g equation in to h. So this x plus 2 is replacing the x. So we'll have 2 times, and replacing x is x plus 2 squared minus 3. Now remember, when something is squared, it means that it is something times itself. So x plus 2 times x plus 2, fill in your box, x squared, 2x, 2x, and 4 means that really this x plus 2 squared is x squared plus 4x plus 4. Distribute that 2 to each of the 3 terms to give us 2x squared plus 8x plus 8 minus 3. And 8 minus 3 gives us 5. So there's our answer.